Hello, my name is Vanessa and I'll be going over my project, which is complex numbers. And my outline, I'll be talking a little bit on my background, and then I'll do the introduction to the complex numbers. I'll give you also some examples on complex numbers. So this is part of the background. Greek mathematician and engineer Hero Alexander is noted as the first to have conceived these numbers. So Hero of Alexandria was a mathematician and engineer who was active in his native city of Alexandria, Rome, Egypt. He attempted to find the volume of a pyramid, which required computing the square root of 81 minus 144. Through negative numbers were not conceived in his Hellenistic world. Geronimo Cordevo was the first to conceive complex numbers in around 1545. He was an Italian polymath whose interest was proficiency ranged from being a mathematician, physician, biologist, chemist, astrologer, astronomer, philosopher, writer, gambler. He was one of the most influential mathematicians in the Renaissance and was one of the key figures in the foundation of probability and the early introduced to the binomial coefficient and binomial theorem in the Western world. He wrote more than 200 words on science. For 6 years, he worked on solving cubic and quadratic equations by radicals. One of the first problems was he hit was the formula. The formula sometimes involved square roots and a negative number, sometimes unheard of at the time. He did the first calculations with a complex number. Okay, so here's a small introduction of what complex and imaginary numbers are. A complex number is a combination of a real and an imaginary number in the form of a plus bi, where a and b are real numbers and I is the unit imaginary number. Imaginary numbers, a number that when squared gives a negative result. Okay, so I'll be explaining this a little bit detail with the examples here. Complex numbers are used quite extensively in engineering. Capacitors and inductors behave as resistors with complex magnitude. One has units like volts and amperes versus watts. So this is just some examples on how they use the complex numbers. Complex numbers are very popular and frequently used aspect of mathematician, composed of real parts and imaginary parts. They are written in the form of a plus bi, where a denotes a real part and bi is an imaginary. Addition of complex numbers is self-explanatory and is done in the same way as you would add any other algebraic terms. The same applies for subtraction. However, multiplication is slightly different. When you multiply out the brackets, you would obtain an I squared term. We know that I squared is equivalent to -1, so this can be simplified. And this is a quick example of how you will be multiplying complex numbers. You can see here is you have 3 plus 4i times -4 plus 7i. If you distribute, you do the FOIL, we get the 12 plus 12, 21i minus 16i plus 28i squared, which we can go ahead and simplify it to -12 plus 5i plus 28i squared, which can be -12 plus 5i, -28, and you get the solution of the -40 plus 51. -40, I'm sorry, -40 plus 5i. Division is also different when involving complex numbers. You must use the complex conjunction of both complex numbers and times both the numerator and denominator by it. The complex conjugates in the same as the original number, except with the opposite sign of the complex part. This makes the bottom multiplication a different and a square of square. Hence, that I term will eradicate, meaning will be left with only the real and I squared term. which, as we have seen from the multiplication, can be simplified to a pure real term. This concludes a part of my presentations of the introduction. If you have any questions, please feel free to comment. Thank you.